Hey, this is Steven from LegitTechTutorials, and welcome to my new tutorial series. This is about intro to computers. So, I'm a computer enthusiast, and if you guys don't know, I have another channel called the Legit PC, where I talk about PC hardware as well as PC games. So, I wanted to share this knowledge with you guys and teach you guys about the basics of computers, what their parts are, and how they work. I'm not going to go super in depth about every different part of the electronic engineering that they use to go into these parts, as I don't really know it all, and you don't really need to know it all to do basically everything with a PC besides, design the parts from ground up. Besides designing the parts. Okay. So I'm going to do this in a order that you would usually buy the parts to build a PC, and that will be in a later series. So so today we're going to talk about processors and what they mean, what they do, what everything it is, what all these numbers and stuff are on here, and how they're used, etc. Alright, so let's go ahead and just wing it and see what happens. Alright, so there are two main manufacturers, companies that produce chips, CPU chips. And CPU stands for Central Processing Unit. But most people just call it CPU, and knowing CPU stands for Central Processing Unit doesn't really get you anywhere. Okay, so there is Intel, and then there is AMD. So here I have one loaded in 4790. So let's go ahead. This is the biggest one now, as it is an i7. Let me explain that. So here's an AMD. So these are the two competing companies, Intel and AMD. I'm going to go ahead and start off with Intel. So Intel, now their consumer-based processors are delegated with an I. So we have all different types. So it goes from the lowest to the highest. So what you have is sometimes you have ones that have no I in it, and those are the lower ones. For example, Pentium, Celeron, etc., etc. And then there's other types of processors called workstation processors that are really high dollar ones that are called Xeon. But usually the easiest way to tell if they are lower grade processors, so it's like the comparison chart between the bottom and the top, the easiest thing to do is look at the price. The slower one is going to have a cheaper price. Now, they have this delegation here. Intel Core just means it's an Intel processor, and it's an i7 4790K. Now, the i7 part means that it's the highest of the i family. It goes, well, as of now, it goes i3, i5, i7. And then the 4790, the higher you go in the number here, the faster it is. And now, Haswell is the name of the design of that processor. Now, you're going to have to do some Googling, as Haswell, they will probably come up with a series after Haswell, so you would have to look that up to know which one is the newest. So they had Sandy Bridge, then they had Ivy Bridge, and now they have Haswell. So those are like three in a row. So it went Sandy Bridge, the next one was Ivy Bridge, and now the newest one is Haswell. And now, so basically that will tell you if it's a brand new technology, and usually each time that they upgrade the technology, it gets more energy efficient and faster, as well as less TDP, which we'll learn in a second, which is less heat. Okay, and then it has this delegation here, which is a quad core. That means that it has 4 cores with 4 threads on board the processor. Basically what cores are they're like little sections. For example, imagine the processor's cut up into 4 sections, and each of the 4 sections could handle a separate task for each of them, rather than just one core that focuses on doing one thing. You have that one core separated into 4 and have it do multiple things at once. So usually we have dual core, quad core, 6 core, 8 core, etc., etc. And then here you have the processor clock. Now this processor clock is determined by the multiplier and the overclocking utility that you use, or in the BIOS, right? Basically, it's the speed. And in most cases, if you have two processors going up against one another and they're both quad cores, the one with the higher clock speed is going to win, is faster. So the higher the clock speed, the faster it goes. But the higher the clock speed, the more heat, etc., etc. And then you get to this delegation here. That delegation is a type of socket that this processor attaches to. So each processor on the backside has little pins that fit into a certain socket that interfaces between the CPU and the motherboard, the main brain, which we'll go over next. That socket is said here. So it says LGA 1150, and it tells you it's a desktop processor, which is what we know, and that this processor fits only in the 1150 socket. So you need 1150 motherboard to work with this Intel processor. And you'll see later on the motherboards. I'll start going over the motherboards. And you'll see, if you remember from this video, you'll see that these two interface with each other. So here you have a little bit of the lineup here. I believe this guy is the Ivy bridge, 4690K. And then you have, the Pentium. Like I said, the Pentium's the lower one. It's delegated with a G. And you can see the clock difference. Yeah, so let's go ahead and go into, I'm on Newegg. It's usually the place I go shopping for parts, and I also like how they have the stuff set up. So I'm going to go into specifications. So there's not really any pictures of the actual processor itself, but it's a little silver disc. You'll see it or just like that. You'll see it when we get around to building a computer from parts. Alright, so if you go into specifications, you'll see everything here. You'll see the socket type. You'll see the core name, right, which is Haswell, quad core. Number of threads, 8. So basically what that means is that this has hyper-threading. So as I was explained, it's got it's like instead of having one hand to grab information for each of the 4 cores, this one has 2 hands. So you could grab and hold information quicker than if you just had one thread. Basically, it just makes it faster. So that means that you have 4 physical cores and 4 virtual cores. So the 8 threads makes it seem like it was an 8-core processor, right? But not quite there. So it maybe speeds up 1.5 times if you have hyper-threading. And this is hyper-threaded enabled processor. Now you see here the turbo max frequency. Basically, the processors these days are very, very energy efficient. They have a standard clock and they have a turbo clock. So the standard clock is what happens when your computer's at idle. It drops the clock down to use less energy and produce less heat. Then when you get onto playing a game or rendering a video or not really surfing the web, but something like that, it will jump into the turbo frequency. And here is the turbo frequency. And another thing is that a term that a lot of people use is that when they change these, that's called overclocking or changing the clock. So they overclock the stock frequency. So let's say, for example, someone overclocked this processor to a 4.4 gigahertz and then the turbo to a 4.8. That's called overclocking. Okay, and this is level 3 cache. Basically, it's like the memory. So the more memory you have, and usually it's megabytes, the more memory you have, the faster it is. So some have level 2, some have level 3, and also this particular one doesn't have that great of details. Let me find Okay, so that particular one didn't have any onboard graphics. This guy, if you see this right here in the name, this is onboard graphics. So that means that if you just have the processor inside your computer and you have no video card, which you'll learn about later, you could basically run your graphics off of this. It has a graphical output, so you could use that to get a video on your screen. While the other one didn't have any. So if you go into the specifications, you see that it says here, integrated graphics. It also says it's hyper-threaded. It says this is the size of the chip, and this is the level 2 cache. So you see that the other one had, I think it was only level 3. So usually if it's level 2, if you have level 2 cache, that's for the graphics. For most of the things that I've seen, it will have. This is a different one. This isn't the one that we looked at a second ago. So this is 4770K, and you see here that it does have integrated graphics. Where are we? Right here. Integrated graphics. Now, there's also a couple other things. You see that it has. This one actually doesn't have level 2, so I guess it's a little different. So if you have level 3 and level 2, it would make it faster. So this has hyper-threading support. So this would have 8 cores, right? 4 physical and 4 virtual. And you see here the last thing that we're going to go over for Intel is the well, actually 2 more. Is the TDP, thermal design power, which basically means how much heat is generated that needs to be cooled. So when you look at this guy, it says 84 watts, and then you need to find a cooler that could cool more than 84 watts. So an average one, like the one I have, is 150 watt cooler, so it could handle 150 watt TDP. So it's, almost twice what I would need for something like this. Of course, this changes if you overclock, blah blah blah. And the final thing is the manufacturing tech. Not really that important, but this basically says like the size of the processor chip. So they change, and usually the smaller, the more efficient, I believe, from what I can remember. Anyways. So let's go ahead and move on to AMD, and you see here this has got 32 nanometers, so it's bigger. Alright, so let's go ahead and go over the name. So this is the FX series, and the larger the number, the higher the more processing power, as well as usually the higher the price, the more processing power it has. Then this is here's the name of the core name, right? The core name is right here, and then this one also has that same progression. As you can see, most of them are all the same. From Intel to AMD, they have very similar naming convention. So this is the core name, or like the core series. Then you have the number of cores. So this is an 8 core instead of a 4 core that you saw, but the other one had hyper-threading, so it's technically 8. Now this is a 4.4 clock frequency, 4.4 gigahertz, so it's faster than the other one. The other one was 4. And here is the socket. The socket is an AM3 Plus, which means it's an AMD socket. And you see here that it has a massive amount of TDP here, 220 watt. And here, usually black edition means that it's like a special edition, like an overclocked edition type thing. And see, the thermal design power is a lot hotter than the other one. The other one was 84. This is 220 watt. So you're probably going to need to use and you see that like a fan. On the other one, it comes with a fan. And you can see here that, and also you can see there in the little window, that the processor's in there in that little viewing window. You can see that you would probably need a water cooling kit in order to cool this, because my one that I have on my computer is 150 watt. So we'll go over cooling later. Alright, so this is 8 cores, and it says the series here, operating frequency, level 2 cache. The size is bigger than the other one. The other one was 22 nanometer. This is 32 nanometer. And yeah, as you can see, no hyper-threading on this one. It is just 8 cores with no hyper-threading. So it's just 8 cores plain. There's no doubling of the cores. Alright, so let's go ahead and see if I could find another one to explain. Let's do like a lower one. As you can see, it's the same. This is a very, very common socket for AMD, the AM3 Plus. You see this is a lower number. It's got lower speed, but you notice the other one didn't have a turbo capability. So it's basically, you know, that one's the extreme version, so it's like it's maxed out all the time. And you notice that also the cost is cheaper. So this is a 4.1 turbo, starts at 3.5. The other one goes all the way to 4.4, and this is a 95 watt desktop processor. But this is a 6 core and not an 8 core. And it explains some more things here. It's got level 2 and level 3. Also, both of those do not have integrated graphics. Usually it'll say that it has integrated graphics. I don't think any of the FX series has integrated graphics. Let's look at like an A10. Alright, so this is a what they call, so I'm going to go over this last processor here. This is what they call an APU, which means Accelerated Processor Unit, which basically means that it has onboard graphics. As you see right here, just like the other one, it had Intel HD graphics. This has AMD Radeon HD 8670D graphics. Because also, there's also another 2 competing companies with graphics cards. So we'll talk about that later. As you see here, it has a 100 watt TDP, but it uses a different socket. It uses the FM2 socket. It also has the turbo boost clock. You usually want to go with something like that, so it scales very well for you know, energy efficiency. And you see it's a quad core. So let's go ahead and look at the specifications really quick. It's quad core. This is the here's the core name is Richland. Then you have the series. Remember the other one was i7. This is the A10, and the previous one was FX. And this one has the 32 nanometer integrated graphics. And here it tells you the integrated graphics. And here it says the TDP. Alright, so that's basically it for processors. We're going to be continuing on, and I'll try to go as in-depth as possible in this series and add in anything that I missed. So if you like this video, please subscribe for more videos like it in this series and other series as well. If you have any questions about this, go ahead and email me. Of course, there's no reference book for this, so I might write one if you guys want. If you guys want to have a book, I might set aside some time to write one. Let me know what you think in the comments, and I will see you guys in the next video. Thanks for watching. Take it easy. Peace.